Let's take a look at the anti-malware protection that the WSA is going to be able to offer us. Looking at the various categories of how we can take our approach to stopping malware, we can start off first with what's called web reputation filters. And this is really pretty intelligent. We're going to take a look at, we look at the URL itself, and that sounds pretty simple. You go, okay, well, I'm going to look at this perhaps fully qualified domain name, or maybe even include the full hyperlink itself, and look for things that could be malicious. And when I think about doing that, I go, okay, well, we've got a reputation score based on previous hostile behavior, right? It's actually a lot smarter than this. One of the techniques I've seen used for delivering phishing attacks and being able to try to circumvent things like reputation lists are buying domains just after they expire. And because a company has perhaps been active for several years, it has this good history, it has sent email in the past, it looks legitimate. So when you take it over as an attacker, you start using it the next day, it doesn't look like it just appeared out of thin air. It has, basically a history of being non-malicious. So one of many things that the web reputation filters can consider is the ownership of the domain. Has it been transferred? Has a registrar been transferred lately? Has the region that the website's in been changed lately? So a lot of the techniques I've seen people abusing for nefarious purposes, those would actually be stopped. And it would be stopped by this solution where it wouldn't be stopped by a lot of the others. So this is something that seems like it might be useful to your organization. Take a little bit of a deeper look at the reputation filter. And now even beyond that, we've got kind of our more traditional approach where we're looking at the content that's coming through the device. So we can leverage those antivirus engines for looking at anti-malware. We support both Sophos and McAfee on that front. And then that's been there for a while. What's a little bit newer onto the scene is the AMP solution. This comes from Cisco directly. So what we're saying there is that we can perform malware detection using third-party engines. We could also perform malware protection leveraging Cisco's AMP solution. And as we go through this section, we'll take a look at how these are a bit different. And then later within the course, we'll do a little bit of a deeper dive into that AMP product. So let's start off by taking a look at the web reputation filters. This is basically a scoring system very similar to what we saw on the email side, on the ESA, and it's going to let us better understand the servers on the far end that our clients are communicating with. So a lot of times when we take a look at a client connecting to a server, within our access policies, within decryption policies, and within our data security policies, we can reference the score of the web reputation filter when selecting our actions. That is to say, we could look at a site, and if it seems very hostile, we could take one action in terms of access or in terms of decryption. And if we look at another site that might be a little bit more hostile, we could, of course, take a different approach there. So here's a nice scale that shows us how that web reputation filter actually works. You'll notice that there's a -10 on the left showing us the most hostile conditions, and then we've got a +10 on the right showing us the most trusted sources. I would imagine, Cisco.com for one, right? We of course want to connect there. We want to grab all of our software updates. We want to grab our definitions and so forth. When we're talking to something that's known good, we may want to pass the traffic. When we're communicating with hosts which are questionable, and if we look at this scale, you can see the majority of the range, from -5.9 to +5.9, we think scanning would be appropriate. And then we go, if it's worse than like a -6, maybe we'll just go ahead and block it. We say if they're that malicious, if they've got that poor of a reputation, let's just toss it out. Now the scale that we're looking at, this is your default. This is going to work for most people. But when you deploy this, keep an eye out. Go ahead, monitor the logs, try to take a close look at what it's dropping. Make sure you're not hitting any false positives. There's a good chance that while this scale works for most people, it may not be perfect for your organization. In that case, you can adjust the scale if necessary. As far as anti-malware scanning, the Cisco WSA anti-malware, and again, this is our web security appliance, uses something they refer to as the DVS engine. And this is going to help us look at traffic and then basically pass it off to the other engine for additional scanning and then get that response back, which is going to give us a verdict on what is the maliciousness of this particular file, right? So we're pulling in the web reputation filter. But in conjunction with the web reputation filter, remember we said if it's between -5.9 and like a +5.9, that we should do a scan. Well, when we scan, what are we going to leverage? We can leverage WebRoot and McAfee or Sophos. You can't do both of them. You pick one or the other here. But basically gives us the ability to perform an additional round of analysis on it. The adaptive scanning engine automatically decides which anti-malware scanning would be appropriate for your type of content. That's what the DVS is going to handle for us. So you think about things like, should we look at PDFs? Of course. Should we look at Office documents and spreadsheets? Yes. Should we look at zip files? Yes. Should we look at PE headers for executables? Of course. You should look at the whole executable. So that's the type of content that we could potentially look at. Again, it comes in and I look at it, I go, do I know that this is a piece of malicious code? If so, I might be able to throw it away right away. If I'm not sure, this is really where we're going to get a lot of value. And that not sure part is where we've got the potential to stop a brand new attack, a day zero attack that doesn't have a good signature out there for it. You go, well, how can you stop a day zero attack? And it varies. We'd have to perform additional analysis, catch it doing something malicious, create a dynamic update, and then push that back to the customer. That sounds like a lot to happen in real time, but I'll show you how that actually takes place. Leveraging AMP, Cisco AMP, this is a whole nother product that we can tie into. It's a security feature and series of products that enables malware detection, blocking, continue analysis, and retrospective security. That's an awful lot. The way that we actually tie that together is, of course, look at the traffic, see if it's malicious. It's nice if we can determine that right off the bat, we'll throw it away. That's what typical anti-malware does. The continuous analysis means when we see new files that we haven't seen before, we can punt them to the cloud, they can get a much deeper level of analysis. And then if we find out after the fact, like, hey, that piece of candy that you ate was actually tainted, that's bad, right? We can look through our retrospective logs and we can see what's happened. When we ran that executable, what did it do? Oh, it modified these 3 other DLLs. Okay, well, good. Let's go take a look at that. Let's track it down and let's see if we can revert what has just occurred. So very, 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 very deep, very intelligent. And it's something that continues to protect your organization in real time, day and night, weekdays or weekends. It just continues to churn away. Under the hood, what it's leveraging is, of course, the file reputation. This is where good signatures come from. The file analysis, this gives us, that deep, and we'll talk about how it gets punted to the cloud and how they do analysis in their sandbox and give us an answer. But through the dynamic logging that AMP-protected endpoints are going to be able to deliver to us, we can see what happens when that victim runs that malicious file. And then, of course, we can kind of put the pieces back together to try to return it to the uninfected or unimpacted state. So what you'll see happening there a lot of times is you'll have your WSA, that may be on-premise, file comes into it, we look at that file, and when I say we look at the file, we're actually just creating a hash or checksum, right? And I go, look at that file, I hash it, I go, hey, how about this hash? And it's known or it's unknown. If it's unknown, well, this is the first time anybody's ever seen that file in the world. Well, at least if Cisco customers looking at the hash. That either means it's a brand new file or it's just never been analyzed before. So if it is something new, if it's something that could potentially be hostile, we could figure it out. What's going to happen there is the WSA is going to talk to AMP in the cloud, and this is just an encrypted session. We basically securely pass the file over to AMP. They've got a sandbox. They can do identification, and they can let us know what happened with that particular file. This is cool because we can leverage all of Cisco's horsepower that's off-premise. So here's what it looks like a little bit closer up. We talk about the ability to do detection, but then also this concept that it's doing continuous monitoring. So the way that the detection works is traffic comes in and we can use this sandbox and we can say, okay, it's potentially a clean file or maybe it's something malicious, right? Let's say that it's malicious and we go, oh no, we didn't figure this out until 15 minutes after the client got the file. Well, leveraging what Cisco calls retrospective analysis, we can say, oh, here's file.exe being downloaded by Jay Smith in accounting. When Jay Smith opened that file, it actually touched these other files, and it'll show you exact times, and it'll give you a nice timeline that you can look at the kind of order of events that happened after this compromise. So we go, okay, they executed the malware, they executed this Trojan, and we get very granular, detailed visibility into what else it touched. Again, that visibility is going to be very, very helpful after the fact when we're trying to determine what's going on with this piece of malware or how badly did it impact our organization. Now, here's a little bit more information about what's happening behind the scenes when AMP detects a file. So a file comes in, let's say WSA is using AMP. AMP creates that SHA-256 checksum and is like, this file is healthy, right? Cloud's like, we've never seen that file before. So you have the opportunity, you can opt into this, where we upload the files to ThreatGrid, and then ThreatGrid's basically going to process it inside of a sandbox. The whole process of sandboxing is very interesting. The sandbox's job is to look like a real computer, look like a real user to that piece of malware. And malware, in the age 2020, ransomware, if you want it to be effective, we've got to consider that somebody might be using a sandbox. So the malware might be smart enough to say, hey, how many CPUs do I have? And if that sandbox only has a single vCPU with a single core, that looks pretty weird. We go, that's not a real computer. That's not a typical end user. I can't target a normal user and find one core. So maybe that's a sandbox. So it's really this game where the malware authors are trying to be sophisticated and intelligent, and before they drop a malicious payload, look and see, do I have a debugger attached? Am I in an emulator? Is time moving faster than time should be? See, if you have a logic bomb, and that logic bomb was going to go off and do some type of malicious behavior at a certain date, we're not going to know by just launching the file. We'd have to launch the file at various dates. So things that sandboxes can do is accelerate time, and it needs to do so in such a way that the client software can't pick up on it or it would shield itself. Again, sandbox technology is a whole separate conversation, but what's neat about it is that the management of sandboxing is, I think, pretty challenging. I took some courses on it previously from Norman. I was thrilled with what the actual analyzer could do, but it's very much its own discipline. By tying into AMP as a customer, you get to leverage all the great capabilities of a sandbox, but you don't have to run it and manage it yourself. You've got the Talos team that's at the controls of this thing, tweaking it, updating it, trying to stay ahead of the attackers. And then our advantage as customers is we get those results back. So here's a little bit of a closer look at the logic behind AMP. Packet comes in, or I guess I should say a file comes in. We look at the file, and it's either a recognized file or unrecognized. If it's recognized, well, we know what this file is, and we have a verdict. If it's good, deliver it. If it's bad, block it. If it's undetermined, the jury's still out, we can use a SCOR. And remember, the SCOR can say, okay, well, if it's maybe above a 3, I'll deliver it to the end user. If it's below that, I'll block. Again, this is your sliding scale as an administrator. You know the type of threats that your company is facing, and they change, right? You might need to adjust it later, but this is a sliding scale on how aggressive we want to be in the blocking process and the delivery process. Now, for unrecognized files, this is where they find what's called patient zero. Who is the first person to ever pick up the coronavirus? Who is the first person to ever be, and that's a real virus, versus who is the first person to be infected by the I love you virus? The whole idea of finding that patient zero is it gets us closer to who the malware author was. Who was the first person that got infected? Okay, who were they talking to? And who is maybe targeting them? So anything unrecognized, that means we haven't seen this checksum before. Okay, it's a unique file. Let's figure out who came in contact with it, where and when, and let's just make sure that it's not anything that's malicious. The integration with Cisco Cognitive Intelligence, this can throw you off a little bit. So when we talk about integrating with CTA, this is a bit different. What the WSA is doing is exporting telemetry data. Just think logs. Who's talking to who, how often, and over what protocols, for how long. And by doing that analytics of your logs and many other customers' logs, we have a good idea of what normal behavior looks like. We've got a real good idea of what malicious behavior looks like. And everything in the middle, we're trying to connect the dots for. Once again, by punting our logs to Cisco, you've got folks at the basically what's called the control system that are controlling the dials and knobs for how aggressive we want to be in detecting of threats, right? And what fields that we want to look at, and what type of decoding we want to perform, and what type of tricks are attackers using to basically bypass detection. And once we figure them out, we can apply it here. So again, this isn't something that we have to basically control and write our own signatures for, right? That's a Talos group that's out here. And based on the things that they see, they can write better custom signatures that identify these threats. We've also got machine learning involved, and it can come back and give us intelligent reports about these are the things that you could be missing. It's right there in your logs, but you hadn't connected the dots yet. That's what CTA can do for you. So a lot of the discussion that we just had regarding looking at potential malware was things coming into the organization or folks downloading things from the internet. What happens when people are uploading? Well, we can still scan outbound traffic and we can still look for attacks, but we don't tend to be as aggressive. We don't tend to think that we're the cause of these day zero attacks. We don't think that we're the ones that are potentially doing all this malicious behavior. So you'll notice that you have a subset of the capabilities on outbound filtering that you do on inbound filtering. And I think that's pretty appropriate, right? I hope your organization isn't, potentially putting out all this malware. But again, we can still scan it just for the likelihood that maybe somebody did get infected. Maybe they picked up a USB thumb drive over lunch and they plugged it into their computer. Now they're sending out files. We can still look at it, but we're just not doing it in an as aggressive of a method, if that makes sense. Here's where you can see your access policies. And you'll notice with inbound and outbound access policies, inbound on top, notice for anti-malware and reputation, they're using web reputation. They're using anti-malware protection or AMP. They're also using anti-malware scanning. What we see down here is just access for web root in Sophos. We don't see AMP down there. You're typically not looking at web reputation for traffic that's leaving you as well. It's typically for things that are being downloaded. The whole idea with web reputation is it a bad guy that's creating the file? Well, you are the person creating the file, sending it somewhere else. So we don't consider that for outbound.